Thanks. Oh, I'm muted?
Yeah, you're muted.
Always. Okay, what's happening? Let me share my screen. Everybody sees my screen? Cool. So it's not demo time yet. Okay, so thanks all for joining. How many? 20 people. Thanks for joining. So I'll be talking about machine learning, especially how it's done on browser. So I'm not even so uh, uh, I haven't done it so much. So uh, what? Yeah, I haven't done it myself so much that, but still, it's that's the point. I want to tell you how easy it is. So yeah, let's start with the agenda. We'll talk about a bit about machine learning, very in surface and not nothing deep, nothing low level algorithms or those maths and stuff. I will talk about neural network, like a bit about that, and then we'll move on to how everything is done on demo. Let me start a timer quickly because I will not have track otherwise. Okay. So let's begin with why. Why do we want to do machine learning? So first reason why machine learning actually is practical than conventional way of writing code is sometimes or in cases where you have lots of possible inputs that you need in making decisions, like one you see on the screenshot. It's a nested ifs and else's, and it can go on and on. So this is like perfect use case when you would turn to machine learning. Sorry, I will be looking this way because I have my screen there. So that's one main reason. And there's lots of data now we have, like internet is filled with data. We have devices, internet of things and everything, creating data everywhere, which can be used to build some really intelligent machines. And we have the resources, the computing capacity now, which is getting cheaper, which is getting more and more available. So it's easier for us to do so. It's no blocker now anymore. So let's begin with the definition. What's machine learning? Even before that, let's start with AI, artificial intelligence. So artificial intelligence, or intelligence itself, means the ability to do to make decisions based on some inputs and like making logical reasoning and then coming into some logical decision at the end. So if we try to do that or mimic that on machines instead of humans, that will be called artificial intelligence. And machine learning is one of the subset of that broader scope, and where the computers are trained, or trained. It's actually called trained, instead of providing it with hard-coded instructions like we do in our usual programming. Sorry. Yeah. So deep learning is just one of the type of machine learning where it makes the machine even more autonomous by removing the requirement to provide the features abstraction, but we don't want to go more into details about that. Let's just move into neural networks. What neural networks is as you see, they're just some nodes connected with some arrows and separated by some layers. So there are 3 layers. First, input, where of course all the inputs are fed, and there's output layer where those nodes actually represent the results, and in the middle there will be a hidden layer which makes this thing actually work. So there's where the learning happens. So we will go into that in a bit, but let's start with what is already possible with these neural networks. So if you just Google it, you will find lots of examples of neural network applications. So one of these was this MAR-IL, which plays the whole Mario on its own without not learning, but by learning itself. So it just uses a neural network and then it just plays by itself. Same thing, Mario Kart, and it's called MAR-IQ. So they are actually using kind of deep learning, I guess, where you're not like, it starts with a baby computer, so baby AI with no knowledge, and it just keeps making mistakes, and it learns. And there's something called reward system, so that it knows when it's doing better by getting those points, and just trying to do that again later, and so on. So those deep neural networks are just the neural networks with more hidden layers, as you see on the second network there. And the first network is general purpose low or shallow, to say, neural network, which can be used for simpler classification tasks. So that's neural network, and the fundamental part, the neuron itself is actually the neural network itself actually is analogous to our how the human brain works, and each node you see there are actually neurons, which is again artificial version of human brain's neurons. So what neurons does is it does a very simple math. So each neuron can accept multiple inputs, and inputs are coming, for example, here. If you look at the hidden layer, all the strings that are attached to it from the previous layer are inputs to it, and it takes all the input, it does this weighted sum, which is just each thread, each connection that is connecting those inputs to itself are weighted, and that will come later on, by some value, and that weight is multiplied to the input value and then added with a bias. It's getting too much, but just it's a simple math. And there's a squishing function, or it's called activation function, that accepts all that, the summation, and then gives you an output. So it's just taking all those zeros and ones, so it's values from 0 to 1, and then doing this math, and at the end the squishing function actually also converts the whole value into some value from 0 to 1, and it sends out the output to the neurons that are waiting for it on the next layer there. So that's how each neuron works. And yeah, it just starts building weights, or it starts manipulating the weights of those strings, and then depending on those weights, the signals that passes through varies every time, and then at the end the output layer will have some values, like different values for different inputs, and that's how it just converts all the input to the results. And there's a phase in machine learning, there's a phase called training phase, where you're training an empty network, as you see on the one before. Let's take one of these. So the first one, take it, and it's empty, the weights are all same or random or whatever, and there's nothing there. And there's a phase called training, where you feed the whole feed the network with some data. So you have historical data with known results. So there are inputs and there's a result to that. When you're training the network, you will take all the inputs, do the prediction, the network tries to predict it, and the output it gives might work or might not work. So if it comes close to desired value, or it deviates and has error, it just goes back and then try to adjust those strings so that the weights change, so that next time the same inputs come in, it will try to the output will be closer to the desired output. So that's how it tries to shape all those weights. And at the end of the training, what's left is all those weights, all those zeros and 0 to 1, those numbers are left in the system. And that actually, at the end, that thing is called model, which will be then reusable to predict more outcomes, like yeah. So, and there's something called learning curve while training, so that's normal, which is shown on this. Actually is not a learning curve, actually, yeah, but yeah, there are a few terms that we need to know. They will be actually useful when you're trying to build your own network. So first of all, loss is, as I said, it's error, like when you're training it, and when it tries to validate the result it predicted with the actual result. If that deviates, then that's called loss. And there's something called learning rate, that is value which makes the compensation, and that's a tuning of compensation. So if you go back to the slide, so you found an error, and now adjusting weights, how much do you want to reduce the weight, or how much you want to tune it up, that's called learning rate. And there are some consequences of having that some value. So there's no right number, but it always depends on your system, and you just tune it to make it work for you. And epochs is the number of times you train your data into your network. So you can do same data set 5 times or 100 times. So every time it just tries to improve on its results, and it does that. But problem, or if you do that a lot, your system might end up being like it's only solving the problems that already is known to it, and kind of not, it won't be that useful for any new data. So there's always this balance of how much you want to do that. And so on learning rate, if you have tuned it to be really high, it can go, like you see on in the end, it goes up and down, because it's trying to change weight so much that your prediction is going way off, and then it just tries, it just oscillates sometimes. But if your optimal, if your values are optimal, then this is the actual curve you want to see. So the on y there's loss, which is the error. You want to see it decreasing by the time your training is done, and the zero value is like it's a perfect network, so you will always be right. But the goal is minimize it as much as you can. And if learning rate is too low, it's going to be flat and will not learn that much. Sure. Yeah, that's yeah, exactly. Yeah. So there's no right value. That's what I said, and you just keep tuning it, and you end up with something that you're satisfied with, and that's it. Um, so convolution layer, I don't want to talk about it right now because I don't think I will have that much time left. But on browser, we have some libraries that makes it quite easy for us to do the machine learning. So TensorFlow was there for some time. It actually makes it possible to do machine learning on your browser on using JavaScript, uh, um, and is not that difficult. But what machine learning does is it abstracts it to, like, it hides all the complex code and makes it really simple to handle most of the cases where you like building a neural network with some standard configuration. That would be like 5 lines of code. And I think P5.js was our topic sometime before in our front-end channel. So P5.js is a visualizing library which is used by ML5, and there's this setup and draw kind of architecture. So setup will be triggered during the initial beginning of the execution. It happens once, so you're just writing setup codes there, and draw will be in a loop. So once setup is done, draw will be called every time, and there's where you just change your current states and then display it somewhere or something like that. So if you look at an example code of an image classifiers are the networks, the classifier models, which can tell or detect, recognize objects in a picture. And one of those models is called MobileNet, and this example is using that, and simply trying to preload the model and an image. So this will be our test object, and during setup it's drawing the canvas, and this is not even that important to us right now because we're not going to see how it looks like on the browser. But yeah, if you're trying to visualize it on your browser, then that's how you start or initialize your canvas. And this one is like one-off classification. It already got the classifier instance here from preload, and it can already classify the given image and get some result. So the callback is defined here. Whatever it gets from result, it's just displaying that. So this classifier will actually, I can show you an example of that. So I'm sorry, why is it so slow?
What a positive example you have here.
Sorry?
A very optimistic example that you have here with your code.
Oh, that. Yeah. So there's a classifier. I think I just played around with the same code example, and what this is doing is it's trying to detect what's no, it's not detecting for some reason. Okay, it's broken. But what it does is it tries to detect what's on the screen and then prints out the label. It says bird or coffee and stuff like that. So that's a classifier. So if you want image detection, like object detection in your image, that's all the code you need. And the classifier itself, the model itself, it's trained with lots of data, like generic data. And if you want your own classifier with your set of data, so specific to your use case, it's not that hard to build your own as well. So it's just creating another instance, training it with your data, and then using it. So it's really easy. So yeah, so own neural network. So the one before was the classifier. This one is as well a classifier, but here we're not using images as input or something. So here this example is just trying to recognize the RGB color. So the inputs are R, G and B values, and it tries to predict if that color looks reddish or bluish. So that's the data set we have, and it's the options are for the neural network you're trying to train. So you can train it as your task is classification, or there might be regression problem like detecting range of values and stuff like that. And that's actually like all the option you have right now. And yeah, initialize the neural network with that option, and your neural network is here as NN. And now take your input data and then do some processing, do some preparation, and then add that data. So for each row, you're just adding it into your neural network, feeding it. And then normalized data is what, yeah, so you're just changing those strings to numbers like 0, 0.5 or something like that. And then there's training option, as we discussed. Epochs is like how many times do you want to repeat it. Batch size is at any instance how many rows do you want to process. And there actually you can have this learning rate, for example, if the whatever you get doesn't satisfy you. And then now train is the function that takes the training input and then trains it and takes the callback, which is then called. So after the training, this code is asking to classify, and classify is now there is this prediction part. So it's trained, and now you're passing this value, and then calling this classify function with your input, and then you're getting the result here. So handle result was the callback for that function, and your result will look something like this: label red and confidence of 0.8 or something like that. So yeah, those are code samples which you don't have to do much different than that. And there are, for inspiration, there are lots of things being done by people, and this AIJS rocks actually have collection of fun projects by people. You can have a look, and our demo will be a classifier. No, not classifier. Sorry, it will be neural network. This actually failed. I don't know why it's so slow. Oh,
You can turn off your main camera still.
where's my button? It's really slow. I can't see the yeah, no, there it is. Yeah, what, maybe I didn't even click the back button. I think this actually is making it slow. The mm. Really? Ah, now it's working there. Cloak and stuff. Okay, thank you. Yeah. So this is like a small UI I built around the classifier code, as we saw before. It it's not that different from that. So it just uses these UI buttons to take inputs from me, and it actually already has some data from before, and you're seeing it, right? So uh, so there is some training data I have already uh, in some file, some JSON file. So there's some inputs like X's are called inputs, and they have inputs like cough yes, cold yes, fever yes, breathing issue yes, and then YS is the results, where yeah, if you have all these symptoms, you have corona. These are like the cases that are already somewhere in your database, or somewhere you can use them to train your model. And what this UI is doing is, you want to add some more cases, like which has already happened. uh, Something is wrong. Yeah, something is wrong. Okay, yeah, that's that. So by just clicking these, I can add rows to those data. I didn't add. Yeah, anyway, so this is the data I actually added just now, and with that you can start training it. I have few shortcuts if they work. ah I don't know.